Hello, this is the math tutor. Welcome. I hope you watched the previous episode of differentiation where we talked about the power rule and how differentiation is applied to everyday life and how we use the power rule to calculate and solve some mathematical problems. So today we are going to continue with the second episode of differentiation. And today we are going to look at the scalar multiple rule. Okay, scalar multiple rule is I'm going to explain the scalar multiple rule and then we shall see some examples. Alright, so yesterday we said that the notation of differentiation is dy dx, or it is f inverse of x. These two mean differentiation. Okay, so if y is equal to k f of x, f of x is, you can call it an equation, and k is a multiplier. That's why it's called a multiple. K is a multiplier. So dy dx will be k and then the derivative of x. So the k, the multiplier, is pulled out, just like we factorize, kind of factorizing, and then we differentiate the rest. Okay, let's try out an example and see how the scalar multiple rule is applied. So differentiate 3x to the power of 4 minus 1 over 2x squared plus 4 over root x and then plus 5 with respect to x. Okay, so this is the question. Before I start explaining this question, you have to remember all the principles that you have studied about indices. Okay, so let's start. So we say let y equal to the function given 1 over 2x squared plus plus 4 over root x plus 5. So dy dx will be 3 is multiplying, so it is pulled out, dx power 4 dx. Half is multiplying, so it is pulled out. Now here, this here is exactly the same as saying half x power negative 2. When the power of x is in the numerator, it becomes a negative. Okay, it is a positive because it is in the denominator here, so we can say a half is pulled out and then we remain with that dx. Hope you're following. Same applies to this here. It's the same as x having a power half. Remember, root x is the same as x power half. But now here the half of the power of x is positive, but when it is pulled up it will become a negative, so it will be like that, dx. And now this the 5x is going to be times x to the power of 0, so we can say 5 into dx power 0 dx. Okay, right. So dy dx now will be, remember, yes, the previous episode we said that the power becomes a multiplier, so it is 3 times 4, and then from the power we take away 1, and then here we have half times negative 2, and then from the power we take away 1. Okay, and then here we have plus, the plus is here, it was there before, so plus 4 times a half, it's negative a half, it is negative a half, don't forget that, and then x power negative a half minus 1, and then this here this part here is the same as 0 because here we can take off 1, negative 1, but the 0 has to multiply the 5, so we get a 0 there, so we remain with nothing. So dy dx will be now 12 to the power of 3 minus, here half 2 cancels with the 2, so minus minus x to the power of negative 3, and then plus 2, this is negative 2 x to the power of negative 3 over 2. Okay, I hope you're still following. And then here we shall get 12x cubed plus okay, we can maintain the minus here, or you can, just a minute, to get this minus, this was negative and negative, so it has to be a plus, sorry, negative here and the negative here, so we have, I'll show you, just a second, I'll erase this. Okay, sorry about that. So we shall have negative, this is x, so negative, this negative here, and then in brackets we had negative 1 and then x power negative 3, so this is how this becomes a plus. Okay, I hope you've seen that. So now here we shall have plus x to the power of negative 3, and then this 2 here will give us a minus 2x to the power of negative 3 over 2. Okay, so this here is the final answer for this question. I hope you understood how to differentiate using the scalar multiple rule, and also thinking about the power rule that we discussed yesterday. Alright, we can talk about another example. By the way, something we need to talk about is sometimes we can say sometimes the differentiation, the dy dx derivatives are also referred to as gradients sometimes. Okay, gradients. Example, you can write this question: find the gradient of the tangent, okay, we all know what a tangent is, to the curve, and the curve is this, x into 2x minus 1 and then x plus 3 at a point 1, 4. Okay, still this question requires you to differentiate. Okay, let's try to solve it. So we can say that since they have already given us y is equal to x into 2x minus 1 x plus 3, okay, we can start by opening the brackets or expanding the brackets. So this is 2x squared minus x, okay, multiplying x plus 3, so this will be 2x cubed minus x squared plus 6x squared minus x squared. Okay, okay, minus x squared, and then minus 3 is the last part. Collecting like terms, we shall have 2x cubed minus just a minute, there's something here that we need to check out quickly, just a minute. So this here is 2x squared, 6x squared minus x squared. Okay, let's open the bracket again. Let's open this bracket again. Just a minute. Alright, we shall take it again. So this is 2x cubed plus 6x squared, okay, and then minus x squared, okay, and then minus 3x, okay. So simplifying this to be 2x cubed, okay, plus 6x squared minus that, we get 5x squared minus 3x. Okay, so this is our curve. So this being our curve, now we shall differentiate. Okay, we shall differentiate. So dy dx, now that we know all the rules, I'll apply them here. 2 dx cubed dx plus 5 dx squared dx minus 3 dx dx. So I've applied the scalar multiple rule that we've just talked about. So dy dx will be 6x and then squared plus 5x and then minus 3. Okay, this is what we have. Okay, so now they gave us a point 1 4, so we are going to, where there is x we shall put in the 1. So x is equal to 1, since this is x and y, coordinate form x y, so x is 1. So our dy dx will be 6 times 1 squared plus 5 into 1 minus 3, and our final dy dx will be 13. Okay, let's first break it down. Let's break it down. So this is 6. Oh, wait a minute. Here, just a minute. Here, the 2 has to come down to meet the 5. So this will be, sorry for that. This will not be 5. It will be 10x, because the 2 comes down to meet the 5. So it gives us 10. So this is 10. Sorry for that. So this is 6 plus 10 minus 3, which gives us 16 minus 3, 13. So therefore, the gradient equals 13. Okay, I hope you guys understand the differentiation. Okay, you can look up for questions about this differentiation, find the gradient of a curve, apply the power rule and the scalar multiple rule. Okay, like you see, we've looked at the scalar multiple rule, we've applied it into 2 examples, and I hope this helps you understand better. We shall continue with our series on differentiation to the end. Subscribe, like, watch, share, because it is always lonely at the top. Bye bye.